Right. Okay. Today laboratory session. So we are going to talk about recursion. We further discuss the recursion, and I'll explain more on that. Then I'll do some practical examples of recursion. And then, as you know, laboratory exercise 5 is available, and then so you have another 2 hours to upload. And actually, it's already over. Today, 12 a.m. Yeah, the assignment is due. So then lab exercise 6. So I hope you are working on this. So you have another 2 days, almost 3 days, right? Like during the weekend, and try to finish this. Okay. Right. So the last lecture, I will upload that today with along with this today's video, right? Okay. So if we go back to our recursion discussion, so as I told you, basically in programming, recursion means calling inside a function, we call the same function. We call that function itself. Right? So the recursion is used basically in programming in situations where we can divide, or we can so we can divide a bigger problem into smaller version of the same problem. If we can divide the problem that we have to solve into similar or a smaller version of the same problem. Like this. In factorial, we identified that factorial means factorial of any number. Factorial of n means n multiplied by n minus 1 multiplied by n minus 2 up to 1. Right? So this is the general definition of factorial. So we can rewrite that. Right? So we can simplify this definition using this. N multiplied by n minus 1, factorial of n minus 1. This is again the same problem. N factorial, so n minus 1 factorial. It is a similar problem, but a smaller version of the same problem. The same similar problem, but smaller version of it. Right? If we can define, if we can define a problem in this manner. So that problem can be solved using recursion. Right? Also, like if you are using a looping or repetition in the program, so almost all those programs can be written using a recursion. If you are using loops, looping is used, those programs can be written in recursion as well. Right? In recursion, repeatedly calling the same function. If you call the same function again and again, that function would be called. I told you it creates a loop, right? So if you have a function, inside that function, if you call the same function, right? If this function is executed, and then it will execute this, and then when this function is called again, it will call to the same function. And then execute, and it will call to the same function. It makes a loop. Right? Okay. So one example that we learned was factor. So did you check this example? Did you check this example and did you try to understand it? So, so did you try to understand this problem? I'll take several minutes, and I'll go through that example again. If anyone who's here who couldn't get exactly what recursion is. In recursion, the function code, that would be the main point that most of the students, beginners, would find difficult to grab, difficult to understand. So let's go with factorial. So yes, so let's copy this one. Right. So I have changed my operating system to Windows 11. So let's see. I didn't check my software, whether they are working properly, the parts are okay and everything. So I didn't check. Let's see.
So give me 1 minute to open the projector. Right, okay. So this is the factorial. So let me remove this. Right, okay. So this is the function. Okay. Then suppose when I call this function, so when I call this function, so I enter value 5 here. Right. So I enter value 5 and click enter. Right. So then this is what's happened, right? The first call for this function with, so this is the function call. Factorial. This is the first function. Right. So the n is 5. Enters here and then check this line. Right. So the n would be 5. 5. So that's the first function call. This is the first function. It will go to this line, check whether n equals 0. It is not true, so then it will skip this part and it will go to else, and then it will go inside and it will execute this part, n 5 multiplied by, then we have a function call. It is calling the same function, but n minus 1. So that means n minus 1, 4. Right. So before returning, before executing this
calculation, right? So first it does this calculation and then return. So that's how it is happening. But before calculating, so one part of this calculation is a function call. So we have to call that function first. So we have this value 5, and the rest of this calculation, we need a function call. So we have to call that function, and we have to wait for the return value. So we call that function. Factorial 4. So this is the second function call. So we are calling the same function. Right? Now this calculation holds. This calculation holds until we get the return value of this. Until we get the return value of this. Okay. Right. So this is the second function code. This is the second function. So in a function stack in the memory, when first function call is done, so then for that function call, stack is added, that function call, factorial function call with number 5. Sorry, actually this is not how it is, like factorial 5. So that means the value of n is assigned with 5. Right, n is assigned with 5, and so other values will be there. So this is the first function code. This is the first function for that function. Then inside that we call that the same function again. It's a different function call. So in memory, it will put the second function call on top of the first function. Second function call is executed first, and then we can go to the first function. And අර මේ උඩින් තියෙන function call එක හැම වෙලාවෙම කරලා ඉවර වෙලා ඒක return value එකක් return කරන්න පුළුවන් level එකට execute කරාට පස්සේ තමයි ඒක අයින් කරලා ඊළඟ එකට කලින් function call එකට යන්නේ. Right? So after executing this function call, then only we can go to the function call. Right? The function 1 is now it holds. Now we are in the second function call, right? The second function call, it comes with factorial function call with value 4. So now in the second function call, n is 4. Right. Okay. So now this is the second function. Second function call. Now forget about the first function call. Now we are in the second function call. So you have to imagine now n is 4. Right. So forget about the past, right? සමහරවිට කියන්නේ අතීතය අමතක කරන්න මේ වෙලාවේ ගැන විතරක් හිතන්න කියලා සමහරවිට. So forget about your A-level results and everything. So just concentrate on this movement. Now this movement in this function call, n is 4, right? So with n 4, so we go inside again to execute the same function, right? Same function, but different function call. So function call is track in the memory using stack. That's a memory stack. Right. So here n is now 4. So we check this. It is not true. So we skip again to else part. Now so I'll now we try to execute this part. N is 4 now. 4 is multiplied by, then we have a function call again. Function call again. So without calling that function, we cannot complete this execution. Right? So we have to call this function again. Right? So now n is 4, n minus 1 would be 3 now. 3. So we call that function again. So this is the third function. Factorial 3. Right? So if I go back to this one, right? So here, to find factorial 4, we have a function. So that is this function call. So inside that function call, we have another function. Right? This is a third function call. So the third function call would be on top of this one. Factorial, whatever the function, 3. So here n is 3. So this is the third function. So from the upper level function calls, lower level function calls are waiting to get the answer from the upper level. උඩ ඉන්න එකන ඒක කැල්කියුලේට් කරලා පල්ලෙහාට ආන්සර් එක අරගෙන එනකල් මේ පල්ලෙහා කට්ටිය බලන් ඉන්න function calls. All these function calls are waiting to get the answer from the upper function calls. මෙයා බලන් ඉන්නවා මෙයාගෙන් උත්තරේ එනකල් තාම උත්තරේ නැහැ. මොකද එයාටත් උත්තරේ ගන්න බෑ. එයාට උත්තරේ ගන්න එයා යන්න ඕනේ තව function call. So it is like sometimes in like government offices. So if you go to, I don't know whether like still you are young, you may not have much experience of going to government offices to do several tasks. Sometimes they have something like that. Like, so we have to. So we first go to one clerk and then so he says, okay, so right, so I can do this part. I can do this part, but you, I need to get the signature from that person. So he mentioned someone, and then I cannot do that until I get the signature. Right. So then that the document is sent to that person, and then he checks, and then he says, okay, like right now, these are okay, but I need to get the approval from this person. So then the document is sent to that person. So likewise, all these function calls are waiting for their boss, right? So this function is called, so the function call 1 is waiting for the function call 2 to give the value. Function call දෙවනි function call එකෙන් උත්තරේ දුන්නොත් විතරයි පළවෙනි function call එකේ calculation එක හදලා value එකක් return කරන්න පුළුවන් වෙන්නේ පල්ලෙහාට. So what is down here? What is down here? This is the main function. So main function එකේ ඉඳලා මේක call කරේ. So this will be the main function. Only function call 2 gives the value to function call 1, then only function call 1 can give the answer to the main function, right? Right. So I'm not going to go through all the steps here, right? Now the function call 3. In function call 3, the value of this one would be now n is 3. So now n is 3. So that value comes here. So n is 3. Goes here, not true, go to else, and then 3 here again, like n is 3 now. Then again we have a function call factorial n minus 1. N is 3 now, n minus 1 means 2. We call the function factorial again with the value 2. That's the fourth function. Factorial with the 2. So now n is 2. So I'll draw that here as well. With the value 2. So now that means n, value of n is 2 now here. This is the fourth function. Right. So now the function called 4. With function called 4, the n's value is 2. දෙක කියන value එකෙන් යා factorial කියලා යා දෙක කියන argument එකෙන් තමයි යා call කරන්නේ. එතකොට n becomes 2. n කියන එක දෙක වෙනවා එතන. In the fourth function call, n is 2. Right. Okay, so we go inside, and then again this is false. We go to else. And then now this value is 2. Okay. And then again factorial. So this function call is there. So in each of these function calls, for example, the first function call, n is 5. Right? So then in that calculation, n is 5 multiplied by, then we need factorial of 4 here. Factorial of 4. Right? But we don't know that. We are waiting for that answer from the right. In fact, call 2, right? N is 4, 4 multiplied by factorial of 3. Factorial of 3, we don't know that. So we are waiting for that answer from function called 3. ඒ කියන්නේ මේ හැම එකේම දැන් එක කෑල්ලක් තියෙනවා calculation එක. අනිත් කෑල්ල සම්පූර්ණ වෙන්න ඊළඟ function call එකෙන් උඩ තියෙන function call එකෙන් උත්තරේ එනකල් බලන්න. ඒ උත්තරේ ආපු ගමන් පට් ගාලා මේ calculation එක මේවා කරලා පල්ලෙහාකට return කරන්න පුළුවන්. මෙතන උත්තරේ ආපු ගමන් so it has to be like this. So it has to be like this. If this is calculated, the answer can be given to this. Right? So likewise, here 3 multiplied by factorial of 2. Factorial of 2. If this can be calculated, that answer can be given here to this place. Right. In this case, 2 multiplied by factorial of 1. This is calculated, so we can give the answer to this place. Okay. So again, here 2, then factorial n minus 1. N is 2, so n minus 1 means 1. Here 1. We call the fifth function call. We call the factorial with value 1. With value 1, we call this one again. N is now 1. But n is 1. We goes here, n equals 1. So still it is false. So we go to else and then return. Here it is 1. 1 multiplied by, we call factorial n minus 1. Factorial n is 1, n minus 1 means 0. Right, so we call the sixth function factorial with 0. Right, so now so let me draw that as well here. Fifth one is we call factorial 1. So that means n is 1 here. Right? So there we have 1 multiplied by factorial 0. If we get the answer of this whole, it can be given to this place. Right? So then the sixth function call is again factorial 0. So that means n is 0. Right. So let's see that function. Now this is 0. N is 0. N is 0. We go inside the function. N equals 0. Yeah, it is true. Then we go here and then return 1. The return 1. So we don't have to go to else. So we go. Now a actually real value is returned. So let's see how it is happening. Now this function, it executes and it returns 1. It returns 1. Right? So by returning 1, it deletes its function call. Now we have return value 1 here. Okay, so the function called 5 was waiting until it gets a value here. Now it received a value. Now this calculation can be done. 1 multiplied by 1, right? So the answer would be 2. Sorry, 1. Sorry, 1 multiplied by 1. It is answer is 1. Right. After returning, so this is returning. Now this function call is returning a value 1. Right. After returning a value, function call can be deleted. Purpose is served. Right now, we don't need this. Now we have a value here. We have a value here. Now the fourth function call was waiting to have a value here. Now it got the value. Now this can be executed. හතරවෙනි ෆන්ක්ෂන් කෝල් එක බලාගෙන හිටියා මෙතෙන්ට වැලියු එකක් එනකල් අර කලින් එකෙන් වැලියු එකක් රිටර්න් වෙච්ච ගමන්ම මෙයාට බලන් ඉන්න දෙයක් නැහැ. ඔන්න වැලියු එකක් ආවා. දැන් එක්සිකියුට් කරන්න පුළුවන්. උත්තරේ 2යි. ඒ උත්තරේ 2 ඊළඟ ෆන්ක්ෂන් කෝල් එකට රිටර්න් කරනවා. ඒක රිටර්න් කරලා මෙයා අයින් වෙලා යනවා. එයාගේ වැඩේ ඉවරයි. So now, so we have this. The function called 3 was waiting for a value, right? So now it got the value from the previous function call, right? Pudding value ekava. Now we don't need to wait anymore. Now it can be calculated. So the answer would be 6 here. So that value can be returned to the next function call. After returning that value, this function call will be deleted. එයාගේ වැඩේ ඉවරයි. එයාගෙන් අපි බලාපොරොත්තු වෙන වැඩේ ඉවරයි. එයාව අයින් කරනවා. Right now, this function call 2 was waiting for a value. Now value was given by the previous function call. So now we can calculate this. Right? So that value can be returned to the next function. Right? So after doing that, we can delete. Right? මගේ වැඩේ ඉවරයි. ඔන්න මම ගියා කියලා. So now we can calculate this one. The function call 1 was waiting to get a value, right? Value was given and then it will be executed. The answer would be 120. So after returning that value, this function call is so this value would be given to the main function. Right. Finally, that value would be returned to this place. So it will be printed. So I hope it is clear. So any questions regarding my explanation? So that's what happening in factorial with the value 5. With any value, so based on the value, the number of function calls would be different.
right, so if I run the code, it will give 120. See? Also, there are several questions. Do you recommend us to use Windows 11? I don't see much difference. Still, I'm not experiencing much difference. So you can see this start icon is here in the middle, right? So like in Unix, Linux systems, so they have similar approach. So other than that, I don't experience much difference. So I experience a bit slow performance, but still I'm taking. So I did it maybe, so I don't remember, like yesterday, like automatic update was happened. Like I downloaded it and then I didn't update it because I've been busy. So I thought like if I miss something, so if something is missing, so then I'd be in there would be trouble for my regular work. But for now, I don't see much difference, right? So I have to check. I haven't checked all the things. You can work with Windows 10 for another 4 years, no problem. So like they are supporting for another until 2025, right? Another several years. So you can just wait, right? You can wait and see how so they are like still Windows 11 is relatively new. So with the time we would understand how it goes. There are pros and cons and everything. So wait. So I recommend you to wait for a while. So and then there's a question. How amount of stack approximately can hold if the n value is very high, right? So good question actually. I told you like in stack, so we put all the function calls on stack, right? So then so definitely there's a limit, right? There's a limit, right? So memory, we don't have infinite memory, right? So we have some amount of memory that we have RAM, right? So what is the limit? Is there a limit in this case? If we put in, actually, definitely there's a limit. I mean, we can call many number of times, but if
the stack is full, we call it stack overflow. Stack is full, then we cannot call any more functions. Stack is full. That could happen if n is really, really big number, right? But usually it is based on your memory. It's based on your memory. So there is, we cannot say this is the limit. It's based on your memory. But usually you don't have to bother on that, right? You don't have to bother on that because it won't take much memory for just one function call, right? So you can call many functions, but if you call a big number of functions, that stack overflow can occur, right? So that's a fact, right? But usually, I mean, in my experience, so I have called many, I have executed many like complicated programs with many number of function calls and so on, but I haven't experienced stack overflow in general programs. Right, okay. So I'll delete this and I'll go to the next one. So I hope now you get the idea of recursion. So we call the same function. Function call is something new. Function call. Function එකයි function call එකයි කියලා කියන්නේ දෙකක්. function එක තියෙනවා. function එක කොහේ ස්ටෝර් කරලා තියෙනවා. ඒ function එකට call කරලා ඒ function call එක කියලා එක තමයි අපි සලකන්නේ. call එක තමයි execute කරන්නේ. ඒ function execution. ඒ function එක execute කරනවා several times. The same function is executed several times. That function call is same as function execution, right? Can function call කරලා execute කරන එක ආපහු කරනවා. ඒතකොට මේ function එක execute කරද්දී ඒකට එන parameters වෙනස් වෙනවා. Right? Like this one. So the parameters were different in each function call. Right, factorial. Again, in when we are finding the power, right? So we can write it in a similar manner. Right? Can you show that coding for a while? Which coding? This one? Okay. right? Okay. So I'm going to change this one to power, right? Okay. Right, so I'm going to change this to power. So in power, right? So we have to get two variables. Two variables. The reason is power. So we have a base and then exponent. We have to find x to the power n, xn, right? Suppose we are going to find this. So we have to get the base. This is the base. So this is not the base case in recursive. So base case and this base is different. Mathematical, in mathematical definitions, we call this base. And then we call it exponent. So we have to get both. Mona padaye kiveni balayada hoyagan. Right? Right. So power. I'm changing that. Power x enter the base. We have to get two numbers. So I'm using two variables here, base and exponent. So power. Base and power. Okay. Enter the base with the base here. Enter the power. We get the power. Then is, and then we call this with base and we get power. Right. So here our exponent it's fine, we can use power, but this function, the name is power. So that's why I changed. Okay. So here, what is a base case? If n is 0, return 1. Same. Any base, the power 0 is 1. So that's the base case. Else, return x, this value, the base, and then our x with n minus 1. හැම වෙලාවෙම මේ base එක x. It does not change, but n is changed. Right. X multiplied by x n minus 1. N minus 1 के power. Likewise, we can call it. Two to the power 2. Then 10. Okay, the answer is 1024. Right. Without much effort, I converted the previous program of factorial into power. So any questions regarding this program? Anything? So here we give two values, base and exponent. So those value comes to x and n respectively. Base come to x and exponent comes to n. ඕනෑම එකක n වන බලය 1යි. එතකොට n කියන්නේ 0 නම් අනිවාර්යයෙන්ම උත්තරයක් අපිට තියෙනවා 1. එහෙම නැත්නම් x වැඩි කරන්න ඕනේ ඊට කලින් එකේ n-1 වල power. x n- ගානක් වැඩි කරාට පස්සේ ඒන උත්තරයට අපි තව x එකකින් වැඩි කරාම x වල n වෙනි බලය. Right.
x වල n වෙනි බලය එනවා x වැඩි කරාම x වල n minus n වෙනි බලය. What are the parameters of function? Power. This function, so these are the parameters. These are the parameters. X is the base, n is the exponent. So can you change it? ඔන්න මේ දෙක මාරු කරන්නත් පුළුවන් nx කියලා ගන්න. nx කියලා ගන්නත් පුළුවන්. හැබැයි එතකොට මේ මෙතනදී මේ දෙක දෙද්දි ඒක හරියට දෙන්න ඕන. එක්ස්පොනෙන්ට් එක දෙන එක බේස් එක දෙන එක හරියට දෙන්න. මාරු වෙනවා. You can put any number. So you can put here exponent and base, no problem. So then, so you have to put base here is again base, exponent. Yeah, exponent. You can put them as well. මෙතන අපි පාවිච්චි කරපු variable number පාවිච්චි කරන්නත් පුළුවන්. So we learned in our variable scope lesson that this ex is different from this ex. So this ex is in main function, this ex is in power function. In two different territories, they don't conflict each other. They exist separately. Okay. Right. So I'm changing. Right. So this is the original one. This is the original program that I written. Right. So then, so if you go to power, this one, and then in Fibonacci case, so I explain what is Fibonacci series. If you want to find the nth Fibonacci number, then so you have to get that using this. n වෙනි Fibonacci number එක ගන්න පුළුවන් n-1 එකයි n-2 එකයි එකතු. So now you can identify, we need to find this is to be solved. To solve that, we need two smaller versions of the same problem. Two smaller versions. එකක් විතරක් මදි දෙකක් ඕනේ. ඒකෙම පොඩි versions දෙකක් හොයන්න ඕනේ අපිට සම්පූර්ණ එක මේවා කරන්න. In the same expression, so we have two similar versions of the same problem. If we have two similar versions of the same problem, so then there should be two recursion calls. We have to call this part separately, this part separately. Right? And then here we identify base cases. If F0 is 1, F1 is 1. 0th Fibonacci number is 0. First Fibonacci number is 1. Right? Here, so this is the example. If n is 0, we can return 0. If n is 1, we can return 1. Because of this. Right? Then, if both of these not happen, if this no, then finally we return so we are trying to find n Fibonacci. In order to find that, we have to call Fibonacci, the same method, so same function with n minus 1, and then we have to add n minus 2. Right, so to calculate this, we don't have any known parts. We call the function here, right? We call the one function call, and then we have another function. In previous case, we had one known part, so we have one function call. But here we don't have known parts, so we have both function calls. So this function call goes separately, and this function goes separately. So in previous case, so there was something that we already know that. Then other part we didn't know, right? So we call someone to go and find the answer. He go and then he call functions again and again, and somehow he comes with the answer. So if we get the answer, then we can calculate this. But in this case, this Fibonacci case, we have two unknown parts. We have to know this and this to add them, separate. So then to find this, we call a function. Right? He goes separately, he calls other functions and other functions and so on. Finally, he comes with the answer. And we have another function called, again, it calls functions and so on. Somehow he'll come with the answer. Only after we got the answer to this and this, we can get the full answer and we can return it. So we call this one and this one, we call the same functions. That's the difference. So මේවට උත්තර හොයාගන්න ඒ කට්ටිය call කරන්නේ එකම function. ඒකයි වෙනස. With different parameter, we call the same function. එකම මනුස්සයාට අපි මේ දෙකේම ගිහිල්ලා කියන්නේ. Right? But two different function call. This comes with a different value, this comes with different value. يعني මෙයත් ඉල්ලන්නේ බනිස් එකක්, මෙයත් ඉල්ලන්නේ බනිස් එකක්. කැන්ටින් එක. මෙයාටත් බනිස් එක දෙන්න ඕනේ, මෙයාටත් දෙන්න ඕනේ. මේ දෙන්නම ඉල්ලන්නේ බනිස්. හැබැයි මේ ඒ කට්ටිය ඉල්ලන වර්ගය වෙනස්. දැන් මෙයා ඉල්ලන්නේ මාළු බනිස්. මෙයා ඉල්ලන්නේ මේ සීනි බනිස් එක. දාන්න. මෙයාට අදාළ එක එයාට දෙන්න ඕනේ මෙයාට අදාළ එක එයාට. Two separate function calls. Two separate function. එකම function එකට call කරාට two separate function calls. Right? So that's the difference. So if we call this so let's right. Okay. Enter positive integer. Or let's write something meaningful. Which Fibonacci number so you can write something like this. Fibonacci number unit. Right. So then you enter that. The value. So D don't worry, like let's make it simple. Yes. The value. Key when Fibonacci number එකද කියලා තමයි මේකෙන්. Right, so it comes to n. Okay. Oh, same twice. Right. Suppose if I enter 5, n is 5, right? Then in this program, right? If n is 5, pass this and pass that, and then skip this, skip that, and then it will come to this. It will call Fibonacci n minus 1. That means the same function with n, so n minus 1. In previous call could be with 4, and it will call the same function with 3. 2 different calls. This call will come here with 4. Let's keep this part and this part, and then now n is 4. It will call three and 2. So call 3 and 2. So this one, it will call 2 and I'll write the next codes. Next codes. This will call 3 and 2. This will call 2 and 1. So 1 would give the answer, but this one again is a call 1 and 0. This both would give the answer 1 and 1. Then it will get this one, and then this one would be. So if we take this one again, the whole 2 and 1. This one it will hold 1 and 0, and then this will get the answer. So this one again 1 and 0, get the answer and get the answer here. So it will get the answer for this one and this one using this recursive function calls. අතු දෙකක් වගේ දෙපැත්තට function calls කරගෙන ගිහිල්ලා sometimes you can see the same function calls can be identified. See, same function calls can be identified. Right? එකම දේ හොයන්න function call කීපයක් ගිහිල්ලා තියෙනවා. But doesn't matter, finally we get the answer. Performance wise, there could be some drawbacks, but still it will work. Right. Right, so don't worry about that. Somehow, so 2 separate branches of function callings are there. Right? Yeah, separately function call. Right. So any questions regarding the Fibonacci problem? Right, so in the meanwhile, so let me give you a few examples, some other examples, right? So
These are very simple programs that you can use recursion. Right? So write a program to print first 50 natural numbers using recursion. Right? So you can do that. So I'm going to delete this, and you can do. It's a very, very simple program. Very simple program. Print first 50 natural numbers. That means like 0 to 49 or 1 to 50, whatever. So the 50 numbers. So let's take this one. 0, 1, 2, up to 49. The easiest way of doing that would be using for loop. Int I equals 0, I assign 0, I goes up to 50. I incremented by 1. I plus, okay. Just printf I. Something like this. How to do this in recursion? How to do the same in recursion? Right? Right. So this is the method that I'm going to use. Okay. So here, no return types. Yeah, we don't need a return type. Okay. Right. So forget about this part. Forget about this part. We just call this one with 50 maybe. Yeah. Oh no, no, no. All right, okay. So yeah. So let's go with 0. So here, if n is less than 50, right? Then so we can print printf n, and then we call same with n plus. Oh, yeah. Yeah, let's go with that. Tab like this up to 40. See, this function goes up to 50, right? You can decide this value. Printf the value, and then we add a tab. After printing the value, I add a tab. And then after printing, we call the same function with n plus 1. First we call with 0, and then the next call it will be 1, it will be 2, and so on. So we can do the same program we did with a for loop with a recursive. Right? Very simple idea. The next one would be write a program to calculate the sum of numbers from 1 to n using recursion. Again, sum of numbers up to n. Write a program to calculate the sum of numbers from 1 to n. Okay. One to n. Sum of these numbers. 2, 3, and so on up to n. So this is same as, this is very similar to what? This is very similar to we have done a similar example in recursion. What is that? Right? N plus n minus 1 plus up to 1. So we have done similar example. What is that? Instead of plus here, if I add multiplication, what would be? Yeah, factorial, exactly. So factorial, only difference is we have plus here. So you can use the factorial, right? Factorial program itself with plus here. Change the name of this. If you add plus here, yeah. So that's Very simple. Now, I'm not going to do that, right? So here, write a program to count the digits of a given number using recursion. Right, so that is a bit interesting. Okay. So here, question number 3. Right? We have to add digits. No, we have to count digits. So, yeah, write a program to count digits, and the next one, write a program to find the sum of digits. Add digits, right? So if like we ask user to enter the value, right? If user enter 257, right? Then here, what we have to do is we have to count how many digits are there. 1, 2, 3. 3 digits. User enter 90. So how many digits? 2. 1, 2. 2 digits. Likewise, count the digits. How can we do that? How can we do that? So one way is you can divide this by 10. If you divide this by 10, get the integer result. Usually, if you divide this by 10, so you get 25.7. Actually, in like integer, we get, right? So we divided by this, and then again we divide it by 10. 2.5, so we get the answer. Again, you divide by 10. Then it would be finally 0.2 something. But we go in the integers, we don't get the decimal points. Right? Again and again, we divide this number by 10. බෙදාගෙන යනවා. උත්තරේ 0. So until the answer is 0. Then how many times we divided? 1, 2, 3. So that's the number of digits. We count the times. How many times that we divide. So again, this one, we can do that. 10 is 9, right? 1 time, and then again we divided by 9, it will be 0. The second 2 digits. Right? To implement this, so we can use for loop, right? So we can use for loop. Number of digits. So I am not writing comments and all here, but when you are writing programs, like don't forget comments. Huh? Right. Number of digits. If any number is inserted here, right? So you can use a for loop. I 0 I equals better to use while loop. While n is greater than 0. Right? n බිඳුව නොවන තාක්කල් n බිඳුවට වඩා වැඩි වෙනකල්, right? What we do is n is divided by 10, and then we assign that value to n. n 10න් බෙදලා a එන උත්තරේ n වලටම අපව දාන්න. So we divide. So this is the n, right? This is the n. We divide n by 10, and then the new answer would be put into the n. Now this is n. n වල value එක අලුත් value එක 25. ආපහු ඒක දානවා මේක. Right? Let's return integer value here. Right? So then we have to count how many times we did that. Int count 0 at the beginning. We return the count. Enter and enter positive integer. Scanf and take a value. Right. So now we can call number of digits with that value. We can use printf. Number of digits in your it will return the number of digits. Let's see whether it works. Yeah. Yes. And then, sorry. Here the count has to be each time. Count has to be increased. Count is 0 at the beginning. Each iteration, the count is increased. Let's see. Yeah, 3 digits. Yeah, 5 digits. So you can use a while loop, right? Similarly, we can do that with recursively calling this function. Right. So I am going to give you the chance, to convert this into recursion. Right. And if I go to the next one, write a program to find the sum of digits. That means the number of digits, not just number of digits, but you need to find the sum of digits. That means 2 plus 5 plus 7. Right. So the answer would be 40. So how to do this? Basically, one way is, right, divide by 10 can be used. Okay. So divide by 10. So here remainder is considered. Remainder is considered. Right. 10 බෙදුවහම කීයද වෙන්නේ? 25යි ඉතිරි 7යි. Remainder is 7. Right. So likewise, we divide that by 10. So the answer is 2. Right. 5. Then again, we divide it by 10. The answer would be 0 and remainder would be 2. See, the remainders are the digits 2, 5, 7. If we add these up, then we get 40. I change this sum of digits, right? We can do that using int sum is 0 at the beginning. And then using while loop, we can do that. N is divided by 10. Right? Before that, we can do is sum would be added with n modulus 10. Assigned the current sum plus. So this can be sum කියලා තියෙන එක අපිට චුට්ටක් වෙනස් කරන්න පුළුවන්. It is the same. It is the same. Then n is assigned with n divided by 10. We don't need count. Count is not necessary. Some can be written. Right. Good work. Let's see. Yeah, it is working. See. Right, so this is the program. Again, I let you do that. Let you convert this into recursion. Right? So you try the last two. You try the last two. You don't have to upload or anything, but you can try and check whether you can do that with recursion. Right, so actually that's all I'm going to do today. That's what time permits. So for arrays, we have to wait for until the Wednesday. So until that, you can work on these examples, and then I will upload another exercise based on so mainly on recursion. Okay, so any questions before concluding today's session? So I'll upload this one as well, so you can try it. Program practice 4, so you can do that. Yeah. So the project deadline is the end of at the beginning of next month. Exact date has not been decided, right? So I was thinking of having the project discussions today, but some of you requested that to have that next week, and also like our so the still I'm not recovered fully, so I'm having difficulties of having long sessions, so asking questions and discussing things. So today I'm not going to have that. Most probably in few days I will inform the times for the discussion. So you can provide your current situation. So if you have problems and everything, so you can explain them, right? If you can create a presentation with, you don't have to spend much time on creating presentation, because like in final presentation, you have to do it with colors and everything. But so in this case, if you have a presentation, that would be sometimes easier, but it is not mandatory to have a presentation slides or something. Right, so I will explain, I'll let you know the next week, definitely next week, Friday or before Friday, so I will have that, like most probably Friday afternoon. So based on the time and the next Friday's schedule. Right, okay, so that's all.
Have a nice weekend, and I'll see you on Wednesday. Okay. Thank you, and stay safe.